One of the things that I look for as a scientist is I would like to go back and see the original references on which guidance was based. I have to say I was unfamiliar with the term explosive polymerization because that made no sense to me in the years of experience that I've had with vinyl chloride. I did manage to track the language down, and for that language, it goes back to something called Bretherick's Handbook of Sensitive Chemicals. It cited two articles published in the early 1970s that, because of their age, can no longer be obtained electronically. But what the language in that, in Bretherick says, vinyl chloride tends to self-polymerize explosively if peroxidation occurs. And we haven't talked much about peroxidation in this, but it's the reason why low oxygen in the presence of vinyl chloride is a stabilizer. The reaction that it prevents is a very slow reaction between vinyl chloride and oxygen. Oxygen cannot initiate high polymer. You cannot, with a trace of oxygen in that rail car, polymerize it to a solid. However, if you have excessive oxygen in the presence of vinyl chloride for a long time, you can make a short polymer that is a copolymer of vinyl chloride and oxygen. And that material, if you make enough of it and if you isolate it, is shock sensitive. So what you want to do is to limit that possibility by limiting the amount of oxygen in the presence of vinyl chloride.
Okay. Can you describe any discrepancy between your knowledge of the chemistry of vinyl chloride monomer and the statements that are listed in the safety data sheet?
I don't know that I'm capable of judging the safety data sheet. I didn't assemble it, and I didn't participate in it. And what's more, I'm not an expert on the hazard communication standard. So in that sense, I don't know what exigencies the people who were putting the safety data sheets together are under, or what requirements they have. There may be good reasons for warning about the things that they've warned about. What I can tell you about, though, is my knowledge of the polymerization chemistry and the chemistry of vinyl chloride. And what I can tell you is that you cannot make PVC without an initiator.
Okay. Well, how chemically reactive is vinyl chloride monomer with aluminum and other catalytic metals?
This is another facet that I really wanted to try to run down what the origin of this advice was to understand it. And I believe I did so in two cases. One is in the Encyclopedia of Chemical Technology, and otherwise I also found original references referring to this. In fact, what both of those references are warning about is the presence of trace hydrochloric acid, that is to say, hydrogen chloride, HCl, and water in vinyl chloride monomer. And that if you put impure vinyl chloride monomer that had HCl and water in the presence of aluminum or copper or iron or steel, it would corrode the aluminum, copper, iron, or steel because of the action of the hydrochloric acid. If there is an implication that somehow aluminum, copper, iron, and steel react with pure vinyl chloride, that's simply not correct. But the origin of those statements and those warnings had to do, I would say, more with the purity of the VCM and impurities in it than it does with a native reaction of vinyl chloride and those metals.
Okay. And would you please tell us about the combustion products from burning vinyl chloride monomer?
There's one article in the literature that has done an extensive study of the combustion products of vinyl chloride. And those products generally are carbon monoxide, hydrogen chloride, and under certain circumstances, trace phosgene. And I know that there were news reports during this of phosgene as a potential side product of combustion. The article itself does the combustion in a laboratory in a glass combustor. So it's a bit different laboratory setup than what we had during the vent and burn. One of the places where they got the least amount of phosgene was in the case where they were simply metering vinyl chloride in with enough ambient air to combust it and doing so. So the point here is the conditions under which you do the combustion matter for how much phosgene you get. On the other hand, the author of the article notes that in all of those cases, even with the trace phosgene present, you had well over 600 times as much hydrogen chloride generated. And the author notes that because of that, the area would be untenable regardless of the phosgene.
Okay, and what can you tell us about the risks of venting and burning vinyl chloride from a tank car?
Well, you've seen the pictures, and there's a pretty good risk of a black plume of smoke. You will produce carbon monoxide, which is probably not a risk unless you're directly in the plume. You will produce hydrogen chloride, which, once again, you don't want to be in the plume. Hydrogen chloride is an irritant and would make it very uncomfortable to breathe. The phosgene, as I say, seems to be of less concern in the light of the hydrogen chloride. The action of the plume, I would imagine there would be a strong thermal drive upward at the beginning and some dissipation. On the other hand, all of those combustion products, with the exception of carbon monoxide, have a higher molecular weight than air and might be expected to drift back down toward the ground, especially hydrogen chloride, which will hydrate itself. It will draw water to itself and make very small droplets. Is there more I've missed there? What else would you like to know?
Well, how about the effect of the combustion products on steels and other equipment?
Because of the hydrogen chloride, it would not surprise me if you would find corroded metal somewhere, particularly if it were in the plume, and particularly if the hydrogen chloride were moisturized. Generally, hydrogen chloride is not as corrosive as hydrochloric acid. The water helps with the corrosion process.
Okay, and have you had any previous experience or observations with what vinyl chloride monomer fires and combustion products do with associated equipment?
I don't believe so. Not off the top of my head, no.
And is it possible that the vinyl chloride monomer polymerized as it was venting from the tank car during the vent and burn?
No.
Okay. All right, Mr. Lynham, if you would continue, please.